process. Wow. Now, that's not enough. I can split them up like this into chromatids, and then they actually swap material. Now, this is all happening at the level of the what? Genotype. All right, now what happens here? So I can take a little bit of dad, and I can swap it with a little bit of mom, and I can switch them over. So this one over here is then all dad, dad mom, mom dad, mom. And I can start jumbling the genes, and I can do it all over the chromosome so that it looks like this. And by the way, this works like a precision machine. It is mind-bogglingly complicated. There are enzymes which twist the molecule. There are enzymes which run along it, which cut it in exactly the right space so that when you cross the genes over, you don't make a mistake. You cut one letter too far, the next gene reads, so it's got to be precise. Clockwork. Otherwise, you're going to have jumbled up kids, I'll tell you that. They wouldn't know whether they're Arthur or Martha. And all this mechanism, this complex mechanism, does nothing but increase the variety. How did it come into existence? Chance or design? Now let me tell you something. If you thought sending a man to the moon was a great feat, this is 10 million billion times more complicated than anything like that. If I had to tell you that rocket that took the people to the moon successfully, and the one that landed, plus all the stuff that went along with it, wow! That came about by chance, they'd lock me up. But this is more complicated than that. There may not be one mistake, or else each one of you would have been a cabbage. And yet we must believe it came about by chance. You're welcome to believe it. I have no problem with it. But I just wanted you to realize what you're dealing with. So here we have a cave fish. Can you see that it doesn't have eyes? It's a new species. It doesn't have eyes. Let me tell you something. I think it has the genes for eyes, but being a cave fish, it doesn't need them. So the genes are what? Switched off, deactivated. If you go to Hawaii, you will find that very quickly after a new cave system or something forms in those volcanic islands, that the cockroaches move into the dark caves. And within a few generations, none of them have eyes. Do you think that's evolution, or do you think it's just deactivating the genes? It's just deactivating the genes. Look at this creature over here. These are flightless birds. We find flightless rails, we find flightless cormorants, we find flightless anything on islands. The genes are deactivated very quickly. This chicken over here is the next of the brand that will be used by Plucky Plied Chicken, because it doesn't have any feathers, so it doesn't take any plucking. Now that could be a mutation, or it could be a deactivation of genes. In some cases you can mix species, like this is a lepjag, that is a liger, a mixture between a lion and a tiger. This one over here is a wolfen, a mixture between a whale and a dolphin. This one is a zos, a mixture between a zebra and a horse. This one is a zonki. It's a mixture between a zebra and a donkey. Of course, you will say their offspring is not viable. But you get fish that do that, and it's viable. You get insects that do that, and it's viable. And maybe there's a link here to the past. This one over here is a chimera. This is a mixture between a sheep and a goat. But because they don't sexually mix, they actually take the cell of an embryo of each, put them together, put them into a surrogate mother, and this part over here on the right, over there, develops as a goat. This piece over here develops as a sheep. That is a goat. That is a sheep. What's going on in the head, nobody knows. And I always have a little joke for you, and that is, when the Lord comes to separate the sheep from the goats, I'd hate to be this guy. That'll be an explosive experience, right? Okay, let's talk about other things. So, when you get something changing, does that necessarily mean it's evolution, or could it be switching off available information? It could be. Now, all our genes are on chromosomes. And sometimes you can get chromosomes to actually join up. Like here you have a tandem fusion, you have a chromosome, and you have a small chromosome, which we call an acrosomic chromosome, and they link up. Oops. Then I have a long chromosome. But the information is exactly the same from banding studies. Can you see that? Have I changed the information? No. I've just changed the way in which it's going to separate. And now this animal here is the largest antelope in the world. It's the eland, and it has one of those. The chromosomes are fused together. And please notice that it has stripes along its side and that it has twirled horns. This one over here is the kudu. It has stripes and it has twirled horns. This one over here is the lesser kudu. It has stripes. The male has similar horns. This one over here is the nyala, female. She doesn't have horns. There's the male nyala. It has stripes. It has horns. This one over here is the bongo. It has the same fusions. It has stripes. It has the same twirled horns. This one over here is a small little antelope. It's called the sitatunga. It has stripes. It has horns. All different species, but banding study shows the same information. Is this one kind, yes or no? Oh, so how many went into the ark? Here's the wolf. He has 78 chromosomes. 78 short chromosomes. They are the foxes and the other canines. They can have from 30-something, 38 chromosomes to 78. If they have 38 chromosomes, then they're long chromosomes. If they have 78 chromosomes, they're short chromosomes. So they looked and they said, hang on a second, that's the same information that you have in the wolf. So, all the canines, and we know that they can even interbreed. If you take the dingo in Australia, why is it endangered? Because it breeds with a domestic dog. If you take the wolf and you take the coyote, if you take Ontario, the coyotes are larger than elsewhere. Why? Because they're a mixture between wolf and coyote. So, with genetic separation by putting them onto different chromosomes, sometimes they become infertile, but the information is exactly the same. Question: of all the wild dogs, all the wolves, all the coyotes, all the wild canines in the whole world, how many went onto the ark? One pair. That's it. Can you see the number of animals going into the ark just shrinking dramatically? Can you see that? All right. There's the dog race on the left over here. That's the variety you can get. That's built-in variety. On the right over here are wild animals. They're all different species, but they have the same chromosome banding patterns. They're one kind. One kind. Robertsonian fusion is another chromosome fusion. Mice, for example, have this. You have the house mouse, Mus musculus. You have the field mouse, Mus passiovinus. Who cares what they're called? It's just names to irritate students. But nevertheless, their chromosome numbers differ, but banding studies show the same information. You have jumping genes in the gene system. You can take a gene, cut it out, put it into another place, and instantly go from a small mouse to a giant mouse. Wow! So you just take a gene out, splice it into a position where it's read more often, and you have a giant mouse. Instantly. If you splice that gene one letter too far, what will the gene read? Has to be perfect. These are all mechanisms that are in the genotype. You either have to believe, boom, New York City, or you have to believe in a designer, because that's what we're dealing with. Chance or design. Giant mouse, small mouse. So, built-in variety in the gene pool, that's what you have in the dogs. All that built-in variety. Reproductive exchange, the fact that we are male and female. By the way, I'm looking at my clock. I've been motoring like a maniac, so let me just run this by you. The Bible says that Eve was taken from whom? Isn't that neat? Eve was taken from Adam. Now I want to tell you today that I have every single gene that it takes to be a woman. Every single gene that it takes to be a woman. Has a woman got every single gene that it takes to be a man? No. She doesn't have a Y chromosome.